Solving equations with logarithms and exponents. Since logarithms and exponents are inverses, log base b of b to the u power equals u. Taking the logarithm of base b undoes raising b to a power, the same way that subtracting undoes adding or dividing undoes multiplying. The above would be read as, what number would you raise b to in order to get b to the u power? By definition, the answer is u. We will use this to solve equations with exponents. So as you can see, log base b of b to the u power, these cancel out, leaving you with u. This also works when raising a base b to the logarithm with the same base of a number. So b to the power of log base b of u equals u. These cancel out. Raising b to the log base b of u undoes the log b function. If I raise b to the number which I would need to raise b to get u, I will get u. We will also use this to solve equations with logarithms. Let's solve this equation for x. So 10 to the 5x power equals 100. Let's take the log of both sides. We have the log of 10 to the 5x equals log of 100. So log, remember this is base 10 and this is base 10. Since there is no base, that means it's 10. So log base 10 of 10 to the 5x power cancels out the log and the 10. And log base 10 of 100 gives us 2. So we'll take the log of both sides, use the inverse property and simplify. We have 5x equal to 2, x equals 0.4. We know that log base 10 of 100 is 2 because 10 to the second power gives us 100. So this whole thing equals 2. In this case, we were able to do log 100 without a calculator because it's an easy one. 10 squared is 100. But sometimes that step is easier with a calculator. Log of 3x plus 7 equals 2. Alright, so let's raise 10 to both sides of the equation to eliminate the log. So we're going to put 10 raised to log of 3x plus 7 equal to 10 raised to the second power. So then we're going to use the inverse property and solve for x. So 10 squared is 100, and 10 raised to the log base 10 power, these are going to cancel out, leaving us with just 3x plus 7. So when we solve this, we get x equals 31. Since the natural log and a power of e are inverses, taking the natural log undoes raising e to a power. The above would be read, what number would you raise e to in order to get e to the x? By definition, the answer is x. So taking the natural log and raising e to a power undo each other, and we just are left with x. This also works when raising e to the natural log of a number. Raising e to the natural log of x undoes the natural log function. This equation states, if I raise e to the number which I would need to raise e to get x, I will get x. That statement is confusing but true. We will also use this to solve equations with natural logarithms. So e and the natural log will cancel out, giving us x. Solve. E to the 5x equals 4. First, we take the natural log of both sides. The natural log and base e cancel out, leaving us with 5x on the left side, and we have the natural log of 4 on the right side. Then when you plug this in your calculator, we get x is approximately equal to 0.277. Solve. E to the 3x plus 2 equals 8. First, we'll take the natural log of both sides, getting rid of that e, leaving us with 3x plus 2 on the left and the natural log of 8 on the right. Then you just put this in your calculator, the natural log of 8 minus 2 divided by 3, and we get that x equals approximately 0.0265. Solve. The natural log of 13x plus 5 equals 11. Alright, so if we raise e to this power and e to this power, then this and this will cancel out. The e will cancel out the natural log, leaving us with 13x plus 5 equals e to the 11th power. Solve for x, and then we can put this in our calculator, and we get that x is approximately equal to 4,605.